This is the Traxxas Stinger motor. It is a small DC brushed motor designed to power radio control cars and boats. It runs on 7.2 to 8.4 volt battery packs and can put out about 41 watts at around 22,000 RPM for its peak power. The housing subassembly is the chassis of the motor. It has the threaded motor mounts on the front, and it is enclosed by the back plate, which is crimped into the aluminum casing. The motor converts electrical power into mechanical output. Electricity comes in through the leads, through the commutator ring, through the brush carriers, and onto the brushes, where they contact the commutator that goes to the coil.
The third subsystem involves electromagnetic force induction. This process is where force is induced based on the current that flows through the coils and is converted to the mechanical output. This subsystem consists of the V-spring, which holds the magnets in place, and the armature plates and the armature windings, which wrap around the armature plates and through which the current travels.
The armature plates are press-fit onto the drive shaft. They transfer a torque to the drive shaft, which rests on two bronze bushings at either end of the housing. On the drive shaft are a collar and washer to absorb friction and keep the drive shaft located properly between the magnets.
To form the aluminum casing, we start with a stock piece of material which is repeatedly cold forged, punched, and annealed until it reaches its final form.
The backing plate is simply punched and stamped from sheet steel.
The commutator core is injection molded into a mold containing the pickups already. It consists of fused silica, brominated epoxy resin, and several other ingredients to form a heat-resistant, insulative core.
The carbon brushes are simply cut from brush stock.
The armature plates are made of punched, laminated sheet steel and subsequently stacked on top of one another.
The drive shaft is high-quality steel, hot forged, machined, and polished. The bushing is made from patented oil-light bronze. Collars are machined from brass, and washers are made from ceramic.
As can be seen in the original product DFA table, the original number of parts was 48, and the number of interfaces between these parts was 40. Our aim was to reduce this number, both of these numbers, by a significant amount in order to slim down the complexity of the product and also to make assembly briefer. Now, looking at the updated DFA table, we can see that the number of parts has fallen by 3 to 45, and the number of interfaces is now 32 instead of 40. While the number of parts only decreased by 3, the number of interfaces decreased by 8, which will go a long way in simplifying the assembly process.
So the idea of our redesign is to reduce the number of parts and improve the serviceability of the motor. We start with several components here: a steel backing plate, a plastic commutator ring, specially shaped brass brush carriers, brushes, and pins. We reduce it down to one thermoset plastic piece with pins, springs, and brushes the same. This allows us to have replaceable brushes, reduces the weight and the number of parts in the motor. So, principal changes to our design are the backing here on the motor. This is the same casing, same drive shaft, same armature and magnet assembly and everything. So back here, we have the new backing. It will consist of 2 brass pins that are molded, that are fixed in the mold when the piece is molded. Springs coiled around them that rest against a mount here, and the brush, which rides in this channel and is pushed up against the commutator. As the brush wears, the spring slowly contracts and pushes the brush towards the commutator. until it's worn out and ready to be replaced, in which case the spring can be pulled off the pin, a new brush put in, and reassembled. The pins also serve as the lead hookups for the motor. So, removing this, the brass bushing sits down inside the thermoset plastic backing and on the drive shaft. The drive shaft will have all of its components on it, collar, and then like before, inside the can we have affixed the two magnets held in with the spring and the press fit oil light bushing down on the end. That's the whole assembly.